2016, Day 4, Part 1. Security through Obscurity. Finally, you come across an information kiosk with a list of rooms. Each room consists of an encrypted name. Room is real if the checksum is the 5 most common letters in the encrypted name, in order, with ties broken by alphabetization. However you say that. Okay. So this is a real room because the most common letters are A, B, and then there's a tie between X, Y, and Z. Okay, so I still don't understand what we're doing. The 5 most common letters in the encrypted name. Oh, I see. So there's lowercase letters separated by dashes, followed by a dash, followed by a sector ID, and then a checksum in square brackets. Okay, and then okay, so it looks like we need to break it up into this section here, this section here, and then we can throw this out because all we care about is this. We don't care about the sector. Maybe that'll be part of part 2. But we need this section here when we count all the letters, and then we do that section there. All right. Let's do our usual modifications here. This gets a 4. This gets a 4. This gets a 4 and a 4. That gets a 4. And then we go up this. And then we do 2015, 04. And then delete the O. All right, so then we should have an unsolved. Oops. Okay. So I messed something up here. Oh, it's right there. What did I do? AOC 2016-04. What did I mess up? I messed up something. Oh, 2015. Okay, that explains it. And this is 2016. I'm so used to doing 2015. Okay. There we go. So now we just need to unrun. Unsolved. Good. Now we just need to figure out how to solve this. So I guess what we can do is write some test cases. And then say, of the real rooms from the list above, the sum of their sector IDs is 15, 14. Oh, so we do need the sector ID. All right. What is the sum of the sector IDs of real rooms? So I guess what we could do is create a struct that contains the encrypted name, the sector ID, and a checksum. And that way, and then we can just validate. So let's put it down here, struct room, which contains a name, a sector, which is a, I'm guessing it's going to be an integer if we have to sum them all up, and then the code, checksum, which is also a string. And we can impl room. And what we can do is we can generate a room based on another string. And it's just return self. And now we just need to split things up, right? So we want to split on the last dash. And we want to split out the checksum and get rid of this closing bracket. All right, well, what if we do it this way? What if we say we can split once on this open bracket? All right, so let's do this. Let's do, say, room name, room string, let's say, and then checksum is equal to room dot split once on open bracket dot unwrap. And then let's take a look at what that is. Self. I'm just going to return a dummy self name. Sector 0, and then checksum toString. I just want to print out what we got so far so we can see what we're getting. Room stir checksum, and it should just be those two parts of the string. So here in parse, what we'll do is we'll just say let underscore equals room new, and then we can just give it all of these things. Copy, paste. And we can do this one. Copy, paste. And we do this one. Wow. There's a better way to do that. Copy, paste. There we go. And then we have totally real room. Copy, paste. Okay, so then we can just look at them as they run and see if we, ooh. Oh. Let's get rid of the H. Expected structure. Oh, right. Okay, let's just pass it in as a stir. That should be fine. And then I forgot the parens. Okay, so now we've split it up this way. So we just need to strip the close bracket off. Actually, we can just say room stir, right? Okay, and then this thing we need to split on that last minus sign or last hyphen. I guess there aren't going to be no negative sector IDs. I was just thinking maybe it would go dash then a minus sign, but okay. I'm not going to worry about it yet. Let's see if I can get my puzzle input. 2016, day 4. 935 lines. And I like to put it a 0 in front. And there's no dash dash, right? Nope, okay. I wonder if these all decode into something. All right, let's see. So for the room stir, then we want to split it up into the name, and let's see, idx is equal to room stir dot rfind, and that's option usize, and let's just unwrap it. That's a usize, and then we can split the room stir into sector string equal to room stir dot split at, I think it's split at idx. Let's see, unknown. Maybe you don't unwrap it. You must unwrap it. No, I guess you don't. Okay, and then we can print those out. And see what those look like. Those are all empty. Oh, no. Oh, because I put 2 dots. Okay, I messed that up. Okay, but yeah, so they're all negative. But that should be easy to fix, right? We can just say let sector equals negative sector stir dot parse I32 unwrap, and then just as sector. Yep, so that's gone. So now we have positive sector numbers, so we can actually just throw it in there. The name is going to be that part, so we can just call it name. I guess we have to say name to string because it's a stir right now. Yeah. And then the checksum is going to be just this last part without the bracket at the end. What's the easiest way to get rid of that bracket? I guess I can convert it to a string and then checksum is equal to cksum to string. I can make it mutable and then just pop it. Checksum. There we go. All right, that seems to have done the trick. All right, so I think we have this now. We have everything, all the pieces in place. We should be able to actually just now write a validator for the room. Just say if room is decoy or is not decoy or is real. Let's go with is real. Then is real self. And that returns a bool. And that all this is going to do is everything. So what do we need to do? We need to count up all of the characters in the room name and then see if checksum is the 5 most common letters in the encrypted name. So it's always going to be 5 with the ties broken by alphabetization. So what we can do is we can just loop over each of the characters and just set a count in a hash map, right? We can do this. Standard collections hash map. And the hash map will just be the keyed by the character and the value will be the count of that character. So we can say let mute 8 hash map equals hash map new. Just like that. Then we can say for character in self.name.chars. We want to filter out all the dashes. I guess we could say is alphabetic. And then we can just count them and print them. So we'll do the same kind of thing we did here. And just print out the hash map after done. Now what's the there's an entry API that we can use to set and modify. Oh, thank you, Zenitsu. Thank you for the follow. Much appreciated. I always forget the hash map entry API. It's like there's like an entry or insert. Yeah. And it's a mutable reference, so we can just modify it. All right, so we can just say star hash map entry C or insert 0 plus equals 1. And then at the end, we can just say println. We can just dump the hash map out and see what we get. And so now, let's create an array of these guys. Like that. And this just becomes this. Let vec equals vec bang, semicolon, and we can just say, oops, I did something wrong. For v in vec, let room equals room new v, and then we can say println room dot is real. Okay, what did I break? Expected stir found array stir. Oh, yeah. I guess these don't need the brackets here because we're just building an array of strings. How's that? Expected bool found that. So let's just return false. There we go. Okay, so we have a false, 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 false. But that's expected, right? Okay, so now we can see, yeah, we have 5 A's, 1 Y, 3 B's, 1 Z. Okay, so they're not in alphabetical order, but what we can do is we can convert the hash map. Now that we've got all the counts, we can just create an array of a vec that we can sort. How can we do that? Let's say let v equals hm, and let's give it a type. That way the collect should work, right? We can just say vec of char and I32. Iter collect. Let's see if this works. And then we can print out the vector. Oh, right, they have to be in a tuple. Cannot be built from... Oh, okay. Thank you, Russ, for letting me know about that. Let's just make these references directly into the hash map. There we go. Okay, and then we printed out the vector, so we see 1, 1, 5, 1, 3. So now we can sort the vector based on this number, and then still have the character associated with it. So that should work fine. We can say this has to be mutable, and we can say v.sort by AB, and it's what, b.1 dot compare with a.1. And let's see what that does. 5, 3, 1, 1, 1. Perfect. Oh, this said ties were alphabetical. Ties broken by alphabetization. Say that 10 times fast. Oh, okay, so that means that we need to make this a little more complicated. What is this type? Is this an ordering? It is an ordering. What's that in? That's in standard compare, right? Use standard compare ordering. Actually, I could just say if b.1 is equal to a.1, then we want to say b.0 compare with a.0. Else b.1 compare with a.1. And that way I don't have to pull in ordering. Because we know b.1 is going to be an I32, so we don't need to do a compare on it. We can just check for equality. That looks like it did it backwards. So we want to flip these around. Oops. A, B, C, D, E, F, G, H. Right. Okay, and then O, because it has 3. Then A and R, that's alphabetical. E, L, M, N, T. And L, O are both 3s. A and R and T are 2s, and those are alphabetical. E, M, Y, all 1s are alphabetical. So now we have to compare it with this. So this should be O. Okay, so we can just compare it to see if the character is in the string. And we only care about the first 5. So we can say v dot iter dot take 5 for key value. Oh, I don't want to use v anymore then. Let's call this list. And now all we're going to do is, in K, V should be character. Oh, let's do that then. All right. That's interesting. I put 1 ampersand on there and it took away both. See, there's 2 here right now. If I put 1 on there, now it just says char. If I don't care about the value actually, right? I just care about whether it's K, no. Self dot checksum contains K. Then we want to increment the count. Oh, so we can print out the count this way. Let count equals list dot iter dot take 5 dot filter on K underscore. Yeah, and then self checksum contains K. and that's going to be bool. And is there like a count if true or something like that? Why is fold faster than filter count? Maybe that's what we want to do. Fold starting at 0, this thing, and then we need an A. It's an I32. Yeah, okay, so that works. So then we can say if checksum contains, then A plus equals 1. No, A plus 1. Return A plus 1. Is that right? Nope. Oh, missing an else. Okay, so I can say A plus self contains as I32. Yeah, so 5, 5, 5, and 1. Okay, so now all we need to do is return whether or not count equals 5. We can actually put that here, right? And it's always going to be 5 according to the instructions, so I don't have to worry about the size of the thing. Simon, thank you for the follow. Welcome. Okay, so we have true, 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 and false. Who knows if that's right? Let's find out if that's right. This is a real room. True. This is a real room. True. This is a real room, even though it's called not a real room. And then totally real room decoy is not, because it doesn't match. Okay, so and now we just need to sum up all of the sector IDs for the ones that are true. So let's see if we can do that. That means we need to modify this a little bit here and just create rooms, back of room. And then as we parse, we can do that. Oops, let's fix that. This is our test data. And then we need to say self.room.push, room new. All right, this should work. Oops. Test data. And we'll fix this to read in the actual file in a second. Self, missing room. A room, back new. Okay. Right, all this code is dead code. So now we can get rid of this print. We don't need the print. And then in part 1, we're just going to sum up all of the valid rooms. So for r in self rooms, room, I did it singular for some reason, if r dot is real, and then we're going to have a running total. Then we say total plus equals r dot sector. And then the return is create output total. All right, so this should equal 1514. Yes, 1514. Okay, so now let's do it with the real data. Test data is this for v in AOC lib read lines input 2016-04.text. And we get an answer of this. Let's see if it's right. Huzzah! Okay, good. Very good. So is there any cleanup we can do? This is pretty straightforward. I mean, this is a little messy splitting this up, but that's just parsing work. This does the counting. Then we can sort. Let's do it. Let's put the blank line here because that groups things together. And then we have this hard-coded 5, but whatever. And then this just adds up how many entries are in the first. Actually, we can just stop after the first one doesn't contain and just return false. I don't know if that would be simpler. I'm not worried about speed though. I mean, this ran in 36 milliseconds. So, all right. Oops. Let's save that. Yep. Git status, git add, input, git commit -m 2016 day 4 input. Right. I have this thing doing all the testing and all the clippies. 2016 day 4 part 1 in the bag. Let's see part 2. With all the decoy data out of the way, it's time to decrypt this list and get moving. The room names are encrypted by state-of-the-art shift cipher, which is nearly unbreakable without the right software. However, the information kiosk designers at Easter Bunny headquarters were not expecting to deal with a master cryptographer like yourself. To decrypt a real room, I don't know why I inserted real. To decrypt a room name, rotate each letter forward through the alphabet a number of times equal to the room's sector ID. A becomes B, B becomes Z, C becomes A, and so on. Dashes become spaces. I wonder if that's important. For example, the real name for this is very encrypted name. What's the sector ID of the room where the North Pole objects are stored? All right. So I guess first what we can do is get this thing to work. We can write a decrypt function. I was just trying to think here. Test mod. And test. So decrypt name. So we can create a room. Let room equals room new. And we'll give it this, and I guess we don't care whether or not it's a real room. Sure, let's do that. Because we're not going to call is real, we're just going to call decrypt on it. And then we can insert equals at room decrypt is equal to very encrypted name, not toString. Right? The real name for this is this. Let me just copy paste in case I typoed it. There we go. Good. So, and now this should fail because we don't have it. Oh, I'm going to run the tests. There we go. We don't have a decrypt function. All right, so fn decrypt of self. And it's going to return a string. This shouldn't be too bad because if we're just rotating it by this value, I mean, it's just mod 26. Right? And then you add it to this mod 26, and then you get the character back out again. Well, let's see what it takes. So we have the code. Let mod, I don't want to use mod. Let's just say m is equal to self.code mod 26. Oh, it's not called code, it's called sector. There it goes. Sector. There we go. Now it's in I32. All right, so now for each entry in the name, or C in self name chars, we need to say let rotated is equal to C as U8 mod 20, no, I'm going to say plus M mod 26 as char. Right, because we've cut M at 26, so the most this can be, oh wait, we have to subtract off. A. Oh, before we do that, we have to see what kind of character it is, right? Because dashes, we can't do dashes. We have to convert those to spaces. If C is equal to a dash, we have a result here. We say result.push space. Otherwise, we say result.push of this thing. And then we just return result. Is that all we need to do? Oh, and then we have to add A back in, because that's not going to work. Ooh, what failed here? Expected U8 found I. I guess we could do that here. Right? Yeah, and it's all these wacky codes. We got to add A back on. So be A plus this. Another round of parentheses. The test passed. So that's good. So that means that we're properly decrypting this thing. So what's the sector ID of the room where the North Pole objects are stored? How do we know what the room of the North Pole objects are stored? How do we know what room that is? We need to get the sector ID of what? I guess we could just decode them and see. Is there something that jumps out at us? I'm confused. All right, let's find out. This is part 2 for R in self room. I guess we could cache whether or not it's real, but we can just call it again. If R is real, println this R dot decrypt. We can just print them all out. Oh, and then we have to return create output 0. Let's just put 0 in there for now. Run. Oh, okay, so they all decode to something. How do we know where the... I thought there would be like a string saying here. All right, let me try running it here. Is there anything that says objects, maybe? Oh, well, there's something called North Pole Object Storage. Is there any other object string? No? All right, so maybe we can look for that. And r.decrypt equals, then, oops, left that off, return create output r dot sector. .501. Let's see if 501 is right. It is. Okay, so we kind of had to a little bit guess there, but it does say North Pole Object Storage, so it was a very mild guess. I guess we can convert this to no sector found. Bacon here. Let's run Clippy. Clippy's happy. Okay. How is Clippy happy with that? It shouldn't have even compiled. Okay. Git status. Git commit -am 2016. Day 4, part 2. In the bag. All right. I need to lower this music a little bit because it's a little loud for me.